In the last video, you saw the first part of section 5.4, which is the derivative of exponential function, right? And you saw that the derivative of e to the x is the same thing, e to the x, right? So if that is true, then the antiderivative of e to the x is e to the x plus c, because the derivative is the same. So the antiderivative is just the same function plus a constant, right? Now here find the antiderivative of 5e to the x dx. That is the integral of 5e to the x dx, right? So how do I do that? Is just pull that 5 out and then do e to the x dx, right? What is that? That is 5. The integral of e to the x is e to the x, and then you write plus c. That's the final answer, right? But here you don't have just x, you have something else there, 3 minus 2x. So in that case we need to assume that as u, right? So set 3 minus 2x equals to u. Then what do you get? If you find the derivative, then you get negative 2 times the derivative of so derivative of 3 is 0, so the derivative of negative 2x is negative 2, and then dx equals to du. So instead of dx, you can write dx equals to negative 1/2 du if you divide by negative 2 on both sides, right? So here this integral can be written as e to the u times negative 1/2 du, right? Because the dx is negative 1/2 du, and then that is u. So e to the u, that thing, right? So negative 1/2, and you got e to the u du. So we use that formula, right? If there is x and then dx, then e to the x plus c. Since there is u, so it will be negative 1/2 e to the u plus c, right? But what is u though? 3 minus 2x. So the final answer is negative 1/2, and then e to the 3 minus 2x, that is x plus c. That is the final answer. Okay, the similar thing here. So you have e to the negative x to the 4 times on the base it is times negative 4x cubed dx, right? So again what I'm going to do is I'm taking that as u. So set e to the sorry, not e to the, just negative x4, negative x to the 4th equals to u. What is the derivative? It is negative 4x cubed dx equals to du. So this thing will become du. It is e to the u, right? So integral e to the u du. Did you see that? And then that will become e to the u plus c. Okay, and this implies e to the negative x to the 4 plus c, because u is negative x to the 4th, right? So similar thing here. So what do you assume as u? The substitution, this thing as u. Usually the exponent of e is considered as u. Okay, so set x squared plus x equals to u. So find the derivative, 2x plus 1, and then just dx equals to du, because it will be du over dx on the right side, and then you can write in that form, right? So this thing is basically this, and that is du. Now this will be e to the u, right? So e to the u and then du. So it will be e to the u plus c, right? So that will be e to the u plus c. That will become e to the x squared plus x plus c. That's how you write. Okay? So from this, what you can say, let me generalize a little bit about this, how that is happening there. Okay, so what you can see from here is, if you have like, you remember that, what is the formula? Let me write down that formula of what is the derivative of e to the u. So e to the u and then prime is equals to e to the u times u prime, right? So that's why the integral of e to the u times u prime dx equals to e to the u plus c. You see that here is e to the u times u prime dx, right? Here e to the u times u prime dx, right? So here e to the u times u prime. So what is u prime? U prime is negative 2, right? So we need negative 2. Negative 2. That's why we need to multiply by negative 1/2. and then now it is e to the u times u prime, right? So in that case, the final answer is that times e to the u, right, plus c. You can think of that way directly. Okay, guys, you can think of, so you don't need to use, if that is in the form of e to the u times u prime, then you can directly write down e to the u plus c. Okay, guys, all right. So here, what is e to the u? E to the u is, so u is 1 over x squared. What is the derivative of 1 over x squared? Do you know that? What is the derivative of 1 over x squared? Yeah, so you can write this as like e to the 1 over x squared times 1 over x cubed dx, right? You can write that way. You see that now? So what is the derivative of u here? So is the derivative of u is same as x to the negative 2, right? 1 over x squared is same as x to the negative 2. If you find out the prime of that, so that will look like negative 2x to the negative 3. That will be negative 2 over x cubed. That is the derivative of u here, right? If you think that as u, the exponent as u. But we don't have that negative 2 over x cubed, but we have x cubed though. So we can do like this. You see that? You can do negative 2 and then 1 over negative 2. If you do that, you cancel that, but you are not doing anything. Just writing in that format of e to the u times u prime, right? And to balance that negative 2, I'm writing 1 over negative 2 here. So you can write like, you can write here as negative 1/2, right? And then e to the 1 over x squared. It is like e to the u times negative 2 over x cubed. This is like u prime dx. So what is the final answer here then? Negative 1/2. And then e to the 1 over x squared, e to the u plus c, that way. Okay, guys. All right. The next thing I'm going to do here is that one. So again, all this problem, you can again use the substitution method. If you do the substitution method, you just assume that 1 over x squared equals to u, and then negative 2 over x cubed du, dx will be du, and then you solve for 1 over x cubed dx, and then do that way. That is perfectly fine to do. Okay, guys. All right, next one. So here it is not in that format, in this format, right? It is not in that format. So we need to do the u substitution. Usually for the u substitution, if there is numerator and denominator, usually, not always, you assume that the denominator thing as u. So 1 over e to the 2x equals to u. We said that, right? We find the derivative of 1 is 0, so derivative of e to the 2x. What is the derivative of e to the u? E to the u is e to the u times u prime, right? So what is the derivative of e to the, it is like u, right? You see that? So it will be e to the 2x times u prime is 2. And then dx equals to du. So but we need to find out e to the 2x dx, e to the 2x dx. So you divide by 2 on both sides. You get e to the 2x dx equals to 1/2 du. So this is like 1 over u and then du, right? You see that? Because e to the 2x dx is 1/2 du. 1/2 du divided by that thing is u. So you can write 1/2 integral of 1 over u du. So do you remember what is the integral of 1 over u du from 5.2? That is, yes, that is natural log of u, right? So 1/2 natural log of u plus c, right? But what is the value of u? It is 1 plus e to the 2x. 1/2 natural log of 1 plus e to the 2x, right? And then plus c, that way. Okay. All right, guys. So why didn't I write the absolute value here? Is because e to the any exponent is positive, right? So whether it is negative exponent or positive exponent, e to the any exponent is positive plus 1. So this quantity is positive. You don't need the absolute value. It is already positive. Absolute value is needed. If it is negative, then it will change to positive, right? So this is the final answer. Okay, guys. How about this one? So do the same thing. Set e to the x plus e to the negative x equals to u. So what is the derivative of that? It is e to the x plus what is the derivative of e to the negative x? It is like e to the u, right? So what is the derivative of e to the u? E to the u times u prime. So e to the negative x times negative 1. u prime is the derivative of negative x, right, equals to du over dx. So you can write, instead of writing du over dx, what we usually do is write down like this and then write dx here, and then if you multiply, you can think of that way, right, like that, right? So basically we don't, it is not correct to cancel out, but this is another way of writing the du over dx in one side. Another way of writing is the differential form. You can just write as dx, but you can think of that way just for quick and dirty, but it is not exactly correct. You cannot cancel out that, but we write in the differential form that way. Okay, now this can be written as e to the x minus e to the negative x and then dx, right, equals to du. So this numerator thing is basically du and the denominator thing is u, right? So you can basically write 1 over u du, right? So what is the integral of that? Is natural log of u plus c, right? What is the u then? Natural log of e to the x plus e to the negative x, right? And then plus c. Okay, guys? So how about question number 108 from the book? So again, so what you do is, usually if there is a trig functions and there is a function for the angle of the trig function, that will be u, right? So that will be basically, this one is u. So set e to the 2x equals to u, then find the derivative. It is like e to the u format, right? If you find out the derivative, e to the 2x times the derivative of that thing is 2, and then dx equals to du. So what can you do here? It is like e to the 2x times dx, not this e to the 2x. This will be u, like cosecant u, right? Now this e to the 2x and dx will be du, but you need to divide both sides by e to the 2x dx equals to 1/2 du, correct? Now this integral can be written as 1/2 integral of cosecant of u and then du, because e to the x dx will be du. So what is the integral of cosecant x? Do you remember that? It is 1/2 natural log of cosecant u minus cotangent u and then plus c. But what is the value of u? You need to plug in that again. The final answer is 1/2 natural log of cosecant e to the 2x, right, and minus cotangent e to the 2x plus c. There is absolute value there, which is the final answer. Okay, guys, so that is the end of section 5.4, which is the integral of exponential function, or the integral involving exponential function. Okay, guys, thank you very much.